Hello everyone. In this video, we'll discuss about memory management schemes. Memory management schemes are a technique used by the operating system to control and contribute computer memory, allocating portions of memory to various programs to optimize system performance. There are some key schemes included paging, segmentation, demand paging, and swapping. So this is a diagram of the memory management schema. Paging is nothing but the memory management technique that avoids the necessity for the continuous physical memory allocation. Physical memory is partitioned into fixed sized blocks known as frames. How it manages memory, the operating system keeps a page table for each process, mapping logical address to physical address. When a process requires a page, the OS uses the page table to allocate or locate the corresponding frame in the physical memory. Advantages: no external fragmentation, efficient use of memory, it's easy to swap pages in and out of the memory. So there are some disadvantages as well. Internal fragmentation can occur. Overhead of the maintaining page table. Segmentation is nothing but divides the memory into variable sized segmentation based on the logical divisions of programs such as functions, data arrays, or subject, or each particular objects as well. How it manages the memory: the operating system keeps a segment table for each process, which stores the base address and length of the each segment. Logical address constraints of a segment number and offset within the segment. Advantages: supports the logical division of a program, making it easier to manage and protect, allows sharing and protection at the segment level. Disadvantages: external fragmentation can occur, more complex to implement compared to paging. Demand paging. Demand paging is a lazy loading technique where pages of process are only loaded into memory when they are needed, not in advance. How it manages memory: when a process tries to access a page that is not in the memory, a page fault occurs. The operating system that loads the required page from disk into the memory. Advantages: reduces the amount of memory needed to run a process. Faster startup time for process, as not all pages need to be loaded initially. So disadvantages: page faults can cause performance overhead and requires effective page replacement algorithm to handle page fault efficiently. Swapping is nothing but when entire process is temporarily moved from main memory to a storage device to free up the memory of the process. The operating system swaps out inactive process to swap space and swap in inactive process as needed to manage its memory. So these are some advantages: increase the amount of available memory for active process, allows more process to be run currently. Disadvantages: swapping can be time consuming and cause delay, can lead to thrashing if the system spends more time swapping process in and out of the memory than executing them. Comparison of virtual memory and cache memory: the location which is located on the disk and the cache is located near the CPU. Purpose: extends physical memory, speed of the CPU access to frequently used data and instructions. Size are typically much larger than the physical RAM, relatively smaller than compared to the RAM. Access speed is slower compared to the RAM, faster than compared to the RAM. The cache speed and the management is managed by the OS, hardware managed by the CPU cache mechanism. Use: manages a memory used for entire process, stores recently and frequently accessed data and instructions for the CPU. Real world application scenarios in the virtual memory: applications used extensively in modern operating system like Windows, Linux, and Mac OS to allow efficient multitasking and handling of large applications like video editing, software, database, and web servers. Scenarios: enabling running multiple applications simultaneously with each needing physical memory equal to its requirements, thus maximizing system utilization and responsiveness. The cache memory: application utilized in CPUs, storage devices like SSDs, and network devices to speed up data access. Allows also employed in a web browser and other software to store recently accessed data for quicker retrievals. Scenarios: enhances the performance of CPU intensive tasks such as gaming, video rendering, and scientific simulations by minimizing that wait time for data for main memory or storage. Importance of of the memory management schemas in modern computing. Efficiency. Memory management schemas ensures efficient use of available memory resources, optimizing system performance and responsiveness. Scalability facilitate the execution of larger and more complex application by effectively managing memory allocation and access. Reliability. Enhance system reliability and stability by preventing memory leaks, fragmentation issues, and resource conflicts. So in this video, we have learned some different real world cases of the virtual memory and cache memory, where they are used and the application of it, and the difference between the virtual memory and cache memory, and different memory management schemas as well. Thank you so much.